All right, everybody, welcome to the 2017 Calculus AB. It's the AP test video. I'm going to be going over the multiple choice part 8 right now, and listen carefully, question everything I'm saying, because there is a chance that I could make a mistake, right? So just keep an eye open. So, section 1, part A. As you know, you have an hour for 30 questions. For these, you cannot use a calculator. So, let's just go ahead and begin. All right. All right. So for the first question, we want to take the derivative. What you need to know right here is that we have to use the chain rule. So we have 7 times 2x squared plus 5 to the power of 6. You leave the inside alone, but then you multiply times the derivative of the inside. So we get 4. Oh, almost made a mistake on the first question already. 4x. When you simplify that, you get 28x times 2x squared plus 5 to the power of 6. So our first answer is D. Okay, number 2, take the integral. Before I take the integral, I see that I can take out a greatest common factor of 1/3, leaving me with 1 over x plus 4 dx. It's important for me to recognize the GCF because I can then take it out of the integral and focus on the function alone. Now, the antiderivative of 1 over x plus 4 is simply the natural log of the absolute value of x plus 4, plus c, of course. So the answer here is B. Take the derivative using the quotient rule. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. From here, do your best to simplify the polynomial. So we have negative x to the power of 3 minus 2 minus, multiplying the two polynomials, we get 15x to the power of 2 minus 3x to the power of 3 divided by your common denominator. Well, by our only denominator. We can then go ahead and distribute the negative. Divided by our denominator. You know what? I was going to be lazy, but no, I should write everything out. Shouldn't teach you bad habits, huh? And finally, combine like terms. We have 2x to the power of 3 minus 15x squared minus 2 all over x to the power of 3 plus 2 squared. So that looks like it's C. Okay, question 4. So we have a table that gives the velocity in miles per hour. T is times in hours. Using a trapezoidal sum with 3 subintervals indicated by the table, what is the approximate distance in miles the truck traveled from 0 to 3? Okay, using the trapezoidal rule, even if you could forget the formula, the technical formula for a trapezoidal rule, remember that a trapezoid, nope, what the heck? In a trapezoid, you have two sides, A and B, and then you have the height H. But whenever you deal with the trapezoidal rule from a table or from a graph, think of the trapezoid as tilted sideways, right? So think of this as your A, think of this as your B. And then the trapezoidal is kind of like that sideways. So think about A being the first value and think of b as being the value of the function for your next value. So, okay, so if we're going to do the area, we're going to have to do a plus b over 2 times the height plus a plus b over 2 times the height plus a plus b over 2 times the height. And I'm also not using the traditional trapezoidal rule formula that we learned because the width of each trapezoid is different. The height of the trapezoid is the difference between b minus a. And as you can see by the table, that width, that height, is going to be different every time. So for the first trapezoid, we have 20 plus 60 over 2 times h, which again is this. So that's 0.5 plus the next trapezoid, 60 plus 40 over 2 times 1.5 plus 40 plus 30 over 2 times 1. Well, this gives me 80 over 2, which is 40. 100 over 2, that's 50. 70 over 2, 35, equals 40 times 0.5 is 20. 50 times 1.5, that's 75, plus 35. So this is going to be 100, 120, 130. B, let's double check our answers. And yes, B is correct. Number 5, take a derivative and then plug in the square root of 2 pi. So f prime of x equals cosine of u times u prime. Well, f prime of the square root of 2 pi is going to be given by cosine of the square root of 2 pi squared plus pi times 2 times the square root of 2 pi. Okay. Well, inside of the cosine, the square and the square root cancel each other out, giving us 3 pi. Cosine of 3 pi, if you think about your unit circle, 0, pi, 2 pi, 3 pi. My coordinate is negative 1, 0. So cosine of 3 pi is negative 1. Which means my answer should be A. Number 6. If f is the function given by that, then the average rate of change of f on the closed interval from 1 to 5 is, oh man, this is a really easy question, guys. Average rate of change is just slope. This is a math 1 question here. So f of 5 minus f of 1 divided by 5 minus 1 is equal to, right, let's see if we can do this in our heads. If I plug in the 5 into the function right here, I'm going to get 3 times 25 minus 125 minus, now I'm going to do a second one in green. So you're going to plug in the 1 into your function. 3 minus 1 all over 4. So this gives me 75 minus 125 minus 2 over 4. 75 minus 125 is negative 50, negative 52, which is negative 13. B. And that's correct. 7. We have a couple of integrals here, and we want to calculate this one. The integral from -10 to 6. All right. Well, take a look at the previous two integrals. We have a -10, we have a 6, and the other limit of integration matches. So why don't we do this? Take the first integral and flip it around. The integral from -10 to 4 of g of x dx plus the integral from 4 to 6 of g of x dx. This right here basically makes the integral from -10 to 6 of g of x dx. So then we're good to go. Just go ahead and take the value of the integrals. This one right here is -3. The second integral is a +5. I probably should have written it the other way around. And then this equals 8. The answer here is D. And that's what the solutions say. Perfect. We have a function. Which of the following is an equation of the tangent line at a point? Okay. And you know what we need, huh? We need slope and a point. We have the point. We need the slope. So let's go ahead and start by finding the derivative. The derivative of f of x is e to the u times the power of u. No, times u prime. Sorry. Now go ahead and plug in your x coordinate, 3 natural log of 4. Well, this equals e to the power of 3, the natural log of 4 divided by 3 times 1/3. Up on top on the exponents, the 3's cancel. E and the natural log cancel. And there's your slope, 4/3. Now for your tangent line, it's basically a point slope form, right, that you learned in Math 1. It's m x minus x1 plus y1. But in my multiple choice, the y1 is moved over to the other side, and that's fine. Y is equal to 4 over 3 x minus 3 natural log of 4 plus 4. So 4/3 x, boom, A is the winner. Come on, computer, scroll down. Okay, number 9. The graph of a function is shown above. Which of the following expresses the relationship between the 3 integrals stated? Okay, well, the integral from 0 to 2, it's an integral is just area, right? Look at all the positive area that we have. So we have positive area. The integral from 0 to 3 is all of this. So we have positive area, and then we have negative area. So you know what I'm going to do? I'm going to call this region A, and I'm going to call this region B, where A is positive and B is negative. So then the first integral is A. The second integral, I have to write A plus B because I'm already assuming that B is negative, right? Don't put A minus B. B is already negative. Man, maybe that's, hopefully that doesn't throw you off. Okay, the last integral. The integral from 2 to 3 of f of x dx is just the region of B, which again is negative. So we have positive area. For the second integral, we have positive area, but it's just smaller. And for this one, we have negative area. So the answer is D. Because we have positive area but less, and then we have negative area. take the integral. All right, well, for this one, you want to do u substitution. You got something that's complex, right? You got two functions being multiplied. Okay. We're going to go ahead and select this as u because the derivative is going to be an x squared, which is located right here. So u is equal to x to the power of 3 plus 1. Du dx is equal to 3x squared. 1 over 3 du is equal to x squared dx. And I'm going to leave it like that because check it out. This guy is going to get replaced by a 1/3 du. The integral of u to the power of 1/2 times 1 over 3 du. And you know what? I'm also going to go ahead and change my limits of integration. U of 2 equals 2 to the power of 3 plus 1, which is 9. And u to the power u of 0 equals 1. So my limits of integration are now 1 and 9. Well, this antiderivative becomes 1 over 3 u to the power of 3/2. But then you have to divide by this new exponent, right? So, or in other words, say times 2/3. Just basically multiply the reciprocal. Evaluate it from 1 to 9. So 2 over 9 times 9 to the power of 3/2 minus 2/9 times 1 to the power of 3/2. You don't have a calculator here, so you have to know how to deal with your fractional exponents. Check it out. We know the 1/2 is basically a radical, right? An exponent to the 1/2 is the square root of x. So that's like your little side. So then we get 2/9 times 3 to the power of 3. And the square root of 1 is just 1, so that doesn't matter. 3 to the power of 3, well, that's 27. Minus 2/9. This equals 54 over 9 minus 2/9, which is 52 over 9. A. Let me check my answers. And A is correct. Find the derivative at a point. Okay. Implicit differentiation. I can tell right away because we have a mixture of x and y's. So then that means that if you're taking the derivative of a letter that is not x, then that letter is a mystery function. Okay, so like this. 2x plus the first times the derivative for the second plus the second times the derivative for the first minus 3 times the derivative of y is equal to 0. Now, because we are going to be plugging in a point to find the derivative, I'm not even going to worry about simplifying this. I'm going to plug it in right now. 2 times 2 plus 2y prime plus 1 times 1 minus 3y squared is equal to 0. 4 plus 2y prime plus 1 minus 3y squared is equal to 0. 5 is equal to y prime because I moved the y primes to the other side. All right, perfect. A. 11 is the answer. Number 12. The number of gallons in water in a storage tank is modeled by this function. Again, number of gallons. At what rate, aka a derivative. Also, here's another huge clue. Gallons per minute. That's a rate. Is the amount of water in the tank changing at 3? So in other words, they want us to figure out W prime of 3. Well, to do that, we need to first figure out what W prime is, and that's negative 2t. W prime of 3 is equal to negative 6. Easy. Easy money. It's like they're begging us to take easy points. Shown above is a slope field for which of the following differential equations. Okay. Interesting. So you're going to have to guess and check here. Let's see. Okay. Well, here's a big old hint. If y is equal to 4, and you plug in a 4 into the y, it doesn't matter what the x is because this is going to be 0, 0, 0. Oh, shit. Okay. That didn't help at all. Okay. Well, what if we plug in x is equal to 0? At x is equal to 0, we have all these funky lines. I see positive lines. I see negative lines. I even see flat lines. But let's see what happens. If you plug in 0, the first one is going to be 0. The second one, well, it's not really dependent on 0, so the third one's going to be 0, and the fourth one is not dependent on 0. But A and C are always going to be 0, which means the lines should be flat, and they are not, right? So these are out of the question already. Okay, let's see, what else should we test? Let's test a random point. Let's test the point negative 2, negative 1. Something in the third quadrant where both coordinates are negative. Well, for the first one, I have negative 1 times 4 minus 1, which is negative 5 over 4, of course. And for the other one, we're going to have negative 1 squared times 4 minus negative 1 over 4. That's 1 times 5. This one's negative. No line is negative. This one's out. This one's in. There we go. Use whatever strategies you guys can think of. Number 14. The weight of a population yeast is given by a differential equation, by a differential function y, where y is measured in grams and t is measured in days. The weight of the yeast population increases according to the differential equation, where k is a constant. At time t is equal to 0, the weight of the yeast population is 120 grams, and it's increasing at a rate of 24 grams per day. Which of the following expressions is the equation for y? Well, that's the big mystery, right? You want to find an equation for y, which means you need to take an antiderivative. But before you do that, you need to get the y's with the y's, and you need to get the t's with the t's. But there is no t. You're correct. We just have k, a constant. So you move the t's and the k's to one side of the function. And now you can go ahead and take your antiderivative. We have ln of y is equal to kt plus c. Okay. Now, we were told that at t is equal to 0, the weight of the yeast population is 120 grams. So then we can do the natural log of 120 is equal to k times 0 plus c. And that should give me my c. And because I have c, I can go back to my function, the natural log of y, which equals kt plus the natural log of 120. And I can solve for y. But k is still there. K is still bothering me, so we need to find it. So before I move on, let's go do that. We were told that at time t is 0, the weight of the yeast population is increasing at a rate of 24 grams per day. This is basically your y prime. So we can, hey, ojo, we can do that. dy dt is equal to ky. The rate is 24. K is k. And y at t is equal to 0. We know that's 120. There we go. Now we can go ahead and solve for k. This can be reduced. Well, we can reduce it by 2. And then we can reduce it by 12. That's your k. So we have, check out this move. Y is equal to e to the power of 1/5 t plus the natural log of 120. I hope you followed it. Y is equal to e to the power of 1/5 t times e to the power of the natural log of 120. Don't forget your exponential properties of why this can become that. Y is equal to e to the power of 1/5 t times 120. And there it is. B. This question kind of sucks for a multiple choice question because it takes so much. But you still need to learn it, all right? Make sure that you understand it and how to do separation of variables. Because if it's an FRQ, this right here could be worth 4 to 5 points. That on an FRQ is a lot. And that would just be one part of a question. So make sure you're good with your separation of variables. The graphs of the functions f and g are shown. Which of the following statements is false? Okay. Some of you already asked me about this question, and I told you to get back to you. Because the first time I did this question, it got me. Okay. Which of the following is false? A. That one is true. Because if you look at f of x, you're approaching 0 from the right and from the left. So you are approaching 0. It doesn't matter that the point is not solid. A limit is what you're approaching, not what it actually is. Okay, B, that one is true. Because the left-hand limit and the right-hand limit are completely different. So it doesn't exist. So then that leaves us with C and D. And this one looks a little tricky because they both look like they might be true, but one of them is in fact false. So let's go ahead and start with C. If the limit's going to exist, then the left-hand limit must equal the right-hand limit. You know that's true. I literally use that logic for A and B. So check it out. The limit as x approaches 1 from the left of f of x times g of x plus 1 must also equal the limit as x approaches 1 from the right side of f of x times g of x plus 1. So what's the limit for f as you approach it from the left? 0. So we have 0. And what's the limit as you approach think of it this way. If you take this 1 and you plug it in here, what's the limit as x approaches 2 from the left? 1. Okay. On the other side, the limit as x approaches 1 from the right of f. So you approach it from the right, and it's 0. The limit as you approach g of x plus 1, or in other words, 2 from the right side, -1. So this right here becomes 0 is equal to 0, and that's actually true. The left-hand limit and the right-hand limit are the same. So the limit does exist. This one is false. That's your answer. You can use this same logic, this same strategy for D, and you're going to see that you get two different limits. All right, I leave that to you. Number 16. We have a function f. What is the largest open interval on which the graph is both concave up and increasing? Oh, shoot. We have to do a super table. Okay, let's not do all about the word. Let's just do it. F prime of x is equal to 12x minus 6x squared. And if you want to find the critical points, pues you have to set it equal to 0. And then solve this any way you can. So then x is equal to 0 and x is equal to 2. Those are your two critical points. Your second derivative is 12 minus 12x. So when you set it equal to 0, x is equal to 1. That's your other critical point. Now again, you can do a super table, which isn't that bad. Let's just do a super table. So my interval from negative infinity to 0 is my first one, from 0 to 1, 1 to 2, 2 to infinity. You want to pick a number such as negative 10, 0.5, 1.5, and 10. You want to plug it into your derivative to see if it's going to be positive or negative. And I'm actually going to plug it in here because it's pretty easy for me to see what it's going to become. See, if I plug in negative 10, I'm going to get negative and positive, which means that's negative. If I plug in 0.5, positive, positive, so it's positive. 1.5, positive, positive, positive. I plug in 10, positive, negative, negative. So what's the behavior? Decreasing, increasing, increasing, decreasing. Okay, but we also want to figure out which one's concave up. So I'm also going to take that number and I'm going to plug it into the second derivative, which is this one. If I plug in negative 10, I get a positive. If I plug in 0.5, I get a positive. If I plug in 1.5 here, I get a negative. And if I plug in 10, I get a negative. So what does that tell me? Well, it's going to be concave up, concave up, concave down, concave down. So we want to figure out the largest open interval where the graph is both concave up and increasing. Here it is, from 0 to 1. I think there could be a faster way. Let's just explore this, all right? I don't know if it's going to work out, but this is the second derivative test. Second derivative test. You basically take your second derivative and you plug in the critical points of the first derivative, so 0. If you plug in 0, you get 12. Because it's positive, that means we're going to have a concave up function. Then you plug in 2. If you plug in 2 into your second derivative, you get negative 12, which is concave down. Okay. And we already know that at x equals 1, because that's a critical point, it's actually a point of inflection. So it kind of looks like this. At 0, You have a function that is concave up. Dang, but we don't know if it's increasing or decreasing. I might be missing something right now. I'll stop right here before I confuse myself or you guys. But just know that this is also going to be a useful tool. Because if all you're looking for is if something is concave up or concave down, well, you can go ahead and use it. If I confused you, sorry. Just focus on the table right now. I'll think more clearly later. Instead of me thinking on the spot. All right, number 17. A particle moves along the x-axis so that its position is given by this function. What is the first time at which the velocity of the particle is 0? Okay, well, let's go ahead and start by finding the velocity. So it's the first times the derivative of the second plus, here let's fix this, cosine of t, plus the second times the derivative of the first. I feel like this question is very similar, don't you? Now I'm actually wondering if I'm doing the correct one. I'll just keep going. I made it this far. 12e to the negative t times cosine of t. Over here on the right side, we're going to have negative 12e to the power of negative t times sine of t. Okay. Well, oh yeah, I'm confusing it with another question. It was very similar. Something about the acceleration. The first time the velocity is 0 or something like that. Anyways, what is the first time at which the velocity of the particle is 0? So you're going to have to make this equal to 0, but I'm also going to take my greatest common factor. And from here, you can go ahead and split them up. Using the zero product property. Now, for the first one, we're actually going to get undefined because you cannot take the natural log of 0. But for the second one, cosine of t minus sine of t is equal to 0. So you want to figure out a spot in the unit circle, an angle, when they are both actually the same, exactly the same, right? Because one minus the other is 0. And that happens at pi over 4. Let f be the function given. Which of the following is the derivative? Pretty easy, guys. When you take the derivative, the integral cancels. And then you're going to have to plug in the upper limit of integration into all your functions. So tangent of 5x, secant of 5x minus 1. And all of that should be in parentheses because then you're going to multiply times the derivative of the limit of integration, which is just 1, right? So D is the answer. Number 19. We have a function for f. What is the approximation of f of 1.5? Using the line tangent to the graph. Okay. If we had a calculator, we could just take 1.5 and plug it into the to the function, right? We didn't need to. But we need to use the tangent line. We have the point 1.5 comma something. No. I read that wrong. We do want to figure out the approximation for f of 1.5, but our x-coordinate is pi over 2. So we have pi over 2, comma. Let's go ahead and find the y value. F of pi over 2 is equal to 2 cosine of pi over 2 plus 1, which is 2 times 0 plus 1, which is 1. That's your point. Now we need your derivative. F prime of x is equal to negative 2 sine of x. And then we can go ahead and plug in pi over 2. So from here, I know that sine of pi over 2 is equal to 1, so my slope is negative 2. My tangent line, mx minus x1 plus y1. Whoa. Now you can plug in your 1.5. 1.5 minus pi over 2 plus 1. This still seems a little tricky, doesn't it? But look, have no fear. Distribute the negative 2, and that gives you negative 3 plus pi plus 1, which is then pi minus 2. C mero. C. C for number 19. Okay. 20. We have a function which of the following is true. Okay. Well, you should probably graph this one. So here's the idea. If you pick 0, you're going to get negative 2 over 4, which is negative 1/2. If you pick 1, you're going to get negative 1 over 2. If you pick 2, you get undefined. Okay. What if you pick negative 1? If you pick negative 1, you're going to get negative 3 over negative 3, positive 3, 6 over 6, which is also negative 1/2. That should already give you a pretty good idea that for anything that's less than 2, you're going to get negative 1/2. So, a line going that way. Okay, let me fix this. Not 2. I'm going to go ahead and put an open circle. So what happens if you pick other numbers, such as 3? You're going to get 1 over 2 times 1. So you get 1/2. You pick 4 and you plug it in. You're going to get 2 over 2 times 2, which is 4. So you get 1/2. You pick 5. You're going to get 3 over 2 times 3, which is 6. You're going to get 1/2. So there it is again. You get something like that. So let's answer this question. The limit as x approaches 2 is 1/2. Well, that is false, my friend, because the limit does not exist. F has a removable discontinuity. That is false because a removable discontinuity is basically one line with a hole. It has a jump discontinuity. That is true. It has a discontinuity due to a vertical asymptote. No, there is no vertical asymptote here. Okay. This question is pretty darn easy. This is the definition of the derivative, which means that it's asking you to take a derivative and then plug in 3. So f prime of x is equal to 1 over x. F prime of 3 is equal to 1 over 3. There is multiple definitions of the derivative. This is one of them. The other one is the limit as x approaches 8 of f of x plus h minus f of x all over h. Okay, there's 2 common ones. This is the other one. What you see right here is the limit as x approaches h of f of x minus f of h all over x minus h. Actually, I think the way we learned it was with a's, where a is a value. Look it up in your notes. Yep. Which of the following is a solution with the initial condition for x is greater than negative 1/2? Separation of variables. You get the y's together, and I'm going to do this. You get the x's together. Well, they're already there, so just move the dx over. Do your antiderivative. 1/2 the natural log of y equals the natural log of 2x plus 1, but because there's a chain rule, it's going to be a 1/2 right here. To double check it, basically just take the derivative of u, which is 2, so then multiply it by the reciprocal, because we're doing an antiderivative, not a derivative. If that didn't make sense to you, then use u substitution. Okay, and you'll see it. Okay, we know that y of 0 is e. So let's go ahead and plug that. If we plug in 0, no. E, because this is technically your x, right? If you plug in x, you get the y. Equals 1/2 the natural log of 0 plus 1 plus c. This is 1/2 equals ln of 1 plus c. So you get 1/2 is equal to c, because this right here is 0. So now I have this 1/2 the natural log of y is equal to 1/2 the natural log of 2x plus 1 plus 1/2. What I can do next is multiply everything by 2. Then I can use e. And then I can use my properties of exponents to separate that addition. And finally simplify. Keep it in parentheses though. This right here over b. Oh man, it's a lot of talking, guys. I'm feeling it. Okay, but now we're at number 23. The region enclosed by the graphs is the base of a solid. For the solid, each cross section perpendicular to the y-axis. Here, you know what? Let's stop. We have x squared. We have 2x. The cross sections perpendicular to the y-axis, so like this, is a rectangle whose height is 3 times the base. Which of the following expression gives the volume of the solid? Since the cross sections are perpendicular to the y-axis, we have to do an integral from f of a to f of b of the right function minus the left function dy. My right function, which is x squared, becomes the square root of y. My left function, which is 2x, becomes 1/2 y. Where do they meet? X squared. No. You know what? If I do x squared equals 2x, I'm going to get the x coordinate. Yeah, let's just do that. You could also set the y functions equal to each other and solve that. But here, points of intersection. So I subtract 2x from both sides. I can factor out an x, and then I can set them both equal to 0. So I get 2 points, but those are not your limits of integration. Those are the x coordinates. the point is 2 comma something and 0 comma something. You can plug it into whichever function you want to get the other point or the other coordinate. If I plug in 0 into either function, I get 0. If I plug in 2, I get 4. So my limits of integration are from 0 to 4 of the right function minus the left function. The region enclosed is the base of a solid. Each cross-section perpendicular to the y-axis is a rectangle whose height is 3 times the base. Oh, we're talking about volume. Ignore this. This is going to be the area of the cross-section. And if you think about a rectangle whose base is b and the height is 3 times the base, then the area of the rectangle is the base times 3 times the base, which is basically 3b squared. So then we have 3b squared dy, which becomes 3 times the integral from 0 to 4. Now the base of the rectangle is given by the right minus the left function, because this right here is the base of the rectangle at any given time, at any given slice. So the square root of y minus 1/2 y squared dy. Just like it's saying. If the average value of a continuous function is 12, then what is that integral? Okay. Well, what do we know about average value? Average value is 1 over b minus a of the integral from a to b of f of x dx, right? We know the average value is 12, and we can go ahead and use the interval given to us from -2 to 4, which would be 6, of the function f of x dx. Now, I can actually just go ahead and solve for the value of the integral. This would be 72 by multiplying both sides by 6. And that's what the integral is worth. Now go ahead and take this integral. The integral from -2 to 4 of f of x divided by 8. Well, you can just factor out the 1/8. That way you can isolate the integral. And that's pretty cool because we know the integral is 72. So 72 divided by 8, well, that's 9. Bam. Watch that. The figure above shows the graphs of the functions f and g. Find h prime of 2. Well, h prime of x is the first times the derivative of the second plus the second times the derivative of the first. Now, if I plug in the 2, I'm finding f of 2 times g prime of 2 plus g of 2 times f prime of 2. F of 2, the graph says 1, 2, 3. It says that it's 3. G prime of 2 is the slope. So the slope is 1, 1, 1, 2. Is it constant though? 1, 1, 2. Yeah, because it's a linear function, of course. So g prime of... I don't need to write it over here. G prime of 2, the slope is -2. G of 2 is -1 according to the graph. F prime of 2 is the slope. So 1, 1, 2. So the slope equals 1/2. The slope equals -2. this is negative 6 minus 1/2. Hold on. G of 2. So, oh, I made a mistake. I knew. I was like, I'm not going to get an answer. G of 2 is 1. Here. I was looking at the wrong thing. So then it's plus 1/2. Which equals negative 12 over 2 plus 1/2, which equals negative 11 over 2. Find the limit to infinity. The limit to infinity. If I plug in infinity right now, it's a little tricky because the exponential grows really fast. The logarithm slows it down. So then the question is, what happens? Which one wins? Okay. So what we can do is we can use L'Hopital's, which means I'm going to take my derivative on the top times. So the derivative is 1 over u times u prime, which is e to the power of 3x times u prime plus 1 divided by 1. It looks kind of messy, huh? But this right here can simplify to 3e to the power of 3x plus 1 over e to the power of 3x plus x. And now that you simplified it significantly, now you can go ahead and take the limit as x approaches infinity of the power functions. 3e to the power of 3x divided by e to the power of 3x. These cancel, giving you 3. Okay. 27. We have f prime, the derivative, shown. Which of the following must be true? F is continuous. Okay. Yes, that must be true. If f is differentiable on an interval, then it's continuous. F is decreasing. No, because this is the derivative. That means it's increasing and then it's decreasing. This is false. 3. The graph of f is concave down. Because this is the graph of f prime and concavity comes from the second derivative, then you're going to have to look at the slope. Look at the slope of f prime. And the slope is negative. So then, yes, it's true. So which ones are true? Seems like it's 1 and 3. C. Let me check my answer. And it's correct. An isosceles right triangle with legs of length s has an area of 1/2 s squared. At the instant when s is equal to square root of 32 centimeters, the area of the triangle area is increasing at a rate of 12 square centimeters per second. That right there is dA dt. At what rate is the length of the hypotenuse of the triangle increasing? So you want to find dH dt. Okay. So we have an isosceles right triangle. We know the legs are the same because it's an isosceles right triangle. So check it out. We can relate S squared, or we can relate s and h by doing Pythagorean theorem. And if you take the derivative, well, actually, first we can combine like terms. And if you take the derivative, you get 4s times s prime, which equals to 2h times h prime. And if we want to find h prime, we need to figure out s prime. So the area, which is 1/2 s squared, if you take the derivative, a prime, then you're going to get 1 times, so this could get a little confusing, right? Because you bring down the 2 times s prime. So a prime is equal to s prime. At the moment, when s is the square root of 32, we know the area is increasing at a rate of 12 squared centimeters per second. We can use that to find s prime. So check, we got s prime. So now I know s, which is the square root of 32. We know s prime, which is 12 divided by the square root of 32. But we don't know h. We're going to have to find h by doing Pythagorean theorem. Oh man, what a problem. Let me go ahead and erase this. We already said that 2s squared is equal to h squared based on Pythagorean theorem. So then 2 times the square root of 32 squared is equal to h squared. 2 times 32 is equal to h squared. 64 is equal to h squared. 8 is equal to h. Only the positive one because it's the length. So then this 8 goes over here into the formula where we can now solve for h prime. Luckily, these cancel, giving us 48 equals 16 times h prime. And when you divide by 16, you get 3. Just barely enough room. 2 more questions to go. The graph of which of the following functions has exactly one horizontal asymptote and no vertical asymptotes? Okay. Well, first let's do the no vertical asymptotes. Take your denominator and make it equal to 0. Let's see if we can figure out a horizontal asymptote. None. B. Take the denominator, make it equal to 0, and see if you can figure out if you have a horizontal asymptote. And yes, you do have a horizontal asymptote, so this one's already out. C. It has a horizontal asymptote, so no. D. And that one has no horizontal asymptote. Or sorry, vertical. What am I saying? These are all for vertical asymptotes, okay? Vertical asymptotes. Now we have to figure out which one has one horizontal asymptote. So a horizontal asymptote happens when you take the limit as x approaches infinity. And if you plug it into the function in a, you're going to basically get infinity squared plus 1, which is 0, which is cool, right? It has a horizontal asymptote. But you also have to check the limit as x approaches negative infinity. And if you plug in negative infinity, well, that's also 0. It checks out. That's the answer. But just to prove it to you, I'm going to go ahead and check D. The limit as x approaches infinity of 1 over e to the infinity plus 1. Well, that number is so big that it's basically 0. But if you plug in negative infinity, you now have e to the power of negative infinity plus 1. Actually, you know what? That plus 1 is so small, it makes no difference. You can basically take it off for all of them if you wanted to. Right? It's insignificant. We're dealing with the power functions here. So what happens when you have a negative infinity as an exponent? Well, it comes to the top, and that is no longer a horizontal asymptote. So there you go. 30. For a certain continuous function f, the right Riemann sum approximation of the integral with n subintervals of equal length is given to that. What is the value of this? So, by definition, the integral of a to b of a function dx is basically the limit as x approaches infinity of a Riemann sum. Of a Riemann sum that starts at any given place. Plus the change of xk times the change in x. So in simpler terms, it doesn't matter if it's a right Riemann sum, a left Riemann sum, an M Riemann sum. You basically want to take infinite rectangles, right? Not just a small amount, infinite rectangles. And here, n is the subintervals, or in other words, the rectangles. But if you want to take infinitely many, then you're basically doing the limit to infinity, right? So you're going to take the limit as n approaches infinity of 2n plus 1 times 3n plus 2 divided by n squared. This is the limit. 2n plus 2, 3n plus 2 over n squared equals 6n squared over n squared. I'm only going to take the power functions because those are the ones that matter, which is equal to 6. And that's what the value of the integral is. 6. Whew, man, that was a long test, eh? So that does it for part A of the multiple choice. I'll see you guys next time for part B.